In this lesson, we're going to look at the fractional distillation of crude oil. Now, crude oil is a mixture. That means it's made up of a whole load of different chemicals which have been mixed together and combined physically, not chemically. So that means that the various components of the crude oil can be separated by a physical process. And the physical process that we use is called fractional distillation. So what is crude oil made of? Well, crude oil is made up of substances, or a class of substances, called hydrocarbons. And hydrocarbons are organic molecules that are made from principally two elements. As the name gives away, these are carbon and hydrogen. Now, we can think of a hydrocarbon molecule as being a molecule with a long chain of carbon atoms with hydrogens joined on to those carbon atoms. And these can consist of gases, which are molecules with the shortest chains. For example, propane is present in crude oil, and butane, where propane is a chain of 3 carbon atoms and butane is a chain of 4 carbon atoms. And after that we have a whole mixture of different liquids, starting with petrol, then naphtha, kerosene, and then diesel oil, and then lubricating oils, and then fuel oils. And fuel oils are used by power stations to produce electricity. So as we move down this list, the length of the carbon chain of each molecule is increasing. And as a result of that, the interaction between the molecules becomes greater. So the boiling point of the liquids increases. That's to say, it becomes harder and harder for these molecules to evaporate into the gas state as we move down this list. And so by the time we get to the bottom of the list, the liquids are becoming pretty gooey, and the last substances present in this crude oil will be placed in the solid state at room temperature. For example, we have wax and grease, and finally the heaviest and longest molecules, bitumen, which is used to make asphalt for road surfaces. So how do we separate these substances? Well, we're going to use the process, as I said earlier, called fractional distillation. This involves an apparatus called a fractionating column. And how does this work? Well, when you start heating any mixture of substances, what will happen is this, that the substance with the lowest boiling point will start to evaporate first, or you can say the more volatile substances will start to evaporate first. So clearly at the very top of this list we have actually gases that are contained within the oil, and these are going to be the first substances that are going to be released, and they're going to go right up to the top of the tower and they're going to be released here. Okay, so the first substances that are going to be released are the gases butane and propane, and then now the next set of substances that are going to be released are these liquids. So the first liquid fraction to be released will be petrol, which is the most volatile liquid and has the lowest boiling point, and the last liquid fraction to be released at the bottom of the tower or lower down in the tower will be fuel oil, which has the longest chains and has the largest boiling point. Now then, I would like to point out here that when we talk about fractions, we're not talking about an individual substance. So it's not just petrol, but it's always a small range of hydrocarbons that are released at each level. So in the case of petrol, we're talking about a group of hydrocarbons with molecular chains of around about 6 to 9 carbon atoms in length. Whereas engine oils, by that I mean lubricating oils, I should have put lubricating oils here, we mean, for example, carbon chains of around about 18 to 25 carbon atoms in length. So a fraction is a group of compounds, and in the case of crude oil we mean hydrocarbons, present in a mixture with similar boiling points and molecular mass. So going back to our fractionating column, the substances to be released at the bottom of the column will be highly viscous or solid substances such as waxes and grease, or bitumen, which will be the longest molecules with the highest boiling points.